Commonly when we carry out a reaction in the lab, or even if we watch one happen in the atmosphere in our bodies, there's not enough of one of the reactants to react with all of the other reactants. One of the reactants runs out first. In this case we have a limiting reagent. The limiting reagent is the one that runs out first. It's the one that determines how much product we'll get. So let's look at a reaction. Here we've got the reaction of hydrogen and fluorine. 1 mole of hydrogen reacts with 1 mole of fluorine to give HF. We're going to react 5 grams of hydrogen with 10 grams of fluorine. So it looks from the masses as if there's more fluorine present than hydrogen. But we've got to remember that we've always got to work in terms of moles, because moles are proportional to the number of molecules present. Remember to do that, we'll first work out the molar mass. So for hydrogen, it's 2 times 1 to give a molar mass of 2 grams per mole. And for fluorine, we've got 2 times 19, because the atomic mass of fluorine is 19. And to work out the number of moles, we use our equation at the top here, the mass divided by the molar mass. So 5 grams of hydrogen divided by 2 grams per mole, the molar mass, and we've got about 2.5 moles of hydrogen. Similarly for fluorine, 10 divided by 38, we've got about 0.263. So actually we've got a lot less fluorine than we have hydrogen. And the chemical equation says that we need 1 mole of hydrogen for every 1 mole of fluorine. But we haven't got enough fluorine to react for all the hydrogen. Fluorine is the limiting reagent. It's the amount of fluorine that runs out first, and it's the amount of fluorine that determines the amount of product that we can get. So let's carry on. So initially we start off with 0.263 moles of fluorine, our limiting reagent, and 2.49 moles of hydrogen. When the reaction happens, all of the fluorine can react, but only 0.263 moles of the hydrogen can react. 1 mole of hydrogen reacts with 1 mole of fluorine. So if 0.263 moles of fluorine react, only 0.263 moles of hydrogen will react, which means that we're left with no fluorine, but 2.49 minus 2.63, 2.23 moles of hydrogen left. Again, look at the chemical reaction. 1 mole of hydrogen reacts with 1 mole of fluorine to give 2 moles of HF. So if 0.263 moles of fluorine are reacted, we'll get twice as much HF. 2 moles every 1 mole of fluorine, 0.526, because 0.263 moles of fluorine reacted. And then lastly, we can use our equation again, but backwards. The mass is the number of moles times the molar mass to give the masses after the reaction. Most of the hydrogen is left over, none of the fluorine, and we end up with 10.52 grams of HF. Let's look at a second reaction. This time we've got a reaction that involves 2 moles of hydrogen reacting with 1 mole of O2. So for every 2 moles of hydrogen we need 1 mole of oxygen, or for every 1 mole of oxygen we need 2 moles of hydrogen. And in this case we've got 2 grams of hydrogen and 10 grams of oxygen. Again, masses can give us the wrong idea. Let's work in terms of moles. The molar mass of hydrogen is 2, and the molar mass of oxygen is 2 times 16, because the atomic mass of oxygen is 16. Work out the number of moles using the equation at the top. The mass divided by the molar mass. 2 divided by 2 is 1. 1 mole of hydrogen is present. And we've got 10 grams of oxygen. 10 divided by 32 is we've got 0.31 moles of oxygen. Now from the chemical equation, 1 mole of oxygen needs 2 moles of hydrogen. So 0.31 moles of oxygen would need 0.62 moles of hydrogen. We've got enough hydrogen. There's more than enough hydrogen present. Let's look at it the other way around. From the chemical equation, 2 moles of hydrogen need 1 mole of oxygen. We've got 1 mole of hydrogen, so that's going to need 0.5 moles of oxygen. We've only got 0.31 moles of oxygen, so there's not enough oxygen present, so oxygen is the limiting reagent. Whichever way around we look at it, oxygen is the one that's going to determine how much products we get, because it's the oxygen that's going to run out first. We can do a similar thing for gases, but for gases it's easier to measure volumes than mass, but conveniently the volume of a gas is proportional to the number of moles, so we can compare volumes of gases just like we compared moles. We mustn't compare masses, but we can compare volumes. So let's look at an example. Here again we've got 2 hydrogens reacting with one oxygen. We could tackle as we did before this in terms of moles. 2 moles of hydrogen react with every 1 mole of oxygen. But in terms of volumes, 2 volumes of hydrogen are needed for every 1 volume of oxygen. In this question we're asked, which is the limiting reagent when we've got 3 litres of hydrogen and 2 litres of oxygen? From the chemical equation, each litre of hydrogen is half as much, 0.5 litres of oxygen. So we have 3 litres of hydrogen, and that would need 1.5 litres of oxygen. We've got enough. Oxygen is not the limiting reagent. From the other way around, 1 litre of oxygen needs twice as much hydrogen. So every 1 litre of oxygen needs 2 litres of hydrogen, or the 2 litres that we have would need 4 litres of hydrogen, and there's clearly not enough. We only have 3 litres and we need 4, so it's hydrogen that's the limiting reagent. It's the amount of hydrogen that determines the amount of product that we can get.